Basically, what we do is a form of project-based learning, but we do it in this, what we call a studio format. I always thought that there is a lot of value to that training in terms of enhancing, innovation, creative thinking, and collaboration.
My project was all about making 3D printed open source insulin pumps.
The kind of culmination of this work was creating a device that could detect when your mobile devices were being surveilled remotely by the Boston Police Department.
And so what we're working on is leveraging our existing connections in the solar industry kind of here and as well there to get free or very low cost solar panels to work on installing them, like for the schools.
We created educational material surrounding solar panels, so when the solar panels are implemented, hopefully the kids can understand them.
Hey nerds, this episode, Jeannie and I sat down with Saeed Arida, the founder and director of the NuVu School. They have a really cool educational model. They're learning design thinking and process and collaboration, and they're high school students working on really interesting, meaningful projects. So this episode, we're going to talk with Saeed, and we're going to talk with some students about what they've been doing at NuVu. Hey, Jeannie.
Yeah, Brew.
Who's our guest on the Energy Nerd Show today?
Oh, man. We're so excited to be here with Saeed Arida at NuVu. Hi, Saeed. How are you?
Welcome.
It's good to be here.
Great to have you.
So I'll say, first of all, it's great to be back here because we were here years ago, maybe a decade, when our kid was looking to do something a little bit different for school. So can you talk a little bit about when NuVu was founded and what the big idea was?
2016 was the early days when we started thinking about this as a full school. And I would say in 2019, we made really a big commitment that this would be a high school. And for the last 3 years, we've been graduating around 10 to 15 kids. Basically, what we do is a form of project-based learning, but we do it in this, what we call a studio format. And we do it because I'm trained as an architect. And I always thought that there is a lot of value to that training in terms of enhancing, innovation, creative thinking, and collaboration. It's a format of education that existed for 400 years. Architects has been taught this way for a long time. You kind of really have to be innovating at every instance and at every project. And so there are a lot of practices within the studio environment that are just so kind of amazing, and they work within that context. I think one of the biggest things is that the instructor gives what we call the problem brief. So they introduce the problem to the students. And I think my theory why there is a high level of engagement from the students is that ultimately it's their ideas that they are implementing. So nobody is telling you you have to learn this and this and this. It's no, we have this problem, we have to solve it. Give me all the ideas that you have to try to solve it. And I think that agency that the students have is really big in terms of creating that commitment to the project and to the ideas that they have. And I would say that the second biggest kind of important part of the studio is the critique culture. And it's in the studio environment is done in multiple stages. One of them is what we call a desk crit, which is when I'm just sitting with the student in a desk or a group of students, but working on the same project. And we talk about the project and we critiquing and give them ideas. Then the second step of it is to do this as a group. So they pin up their work and they call it pin up. And then we, as a group, we talk about the work. And that way other students get to see also what everybody is doing and builds that culture within the studio. And then the final step of it is that when you do the final review and then you bring people from outside. And you get to see perspectives, basically, that you did not hear before. And these things are always kind of, you zoom in into your desk grid, you kind of zoom out to you're hearing more feedback, then you zoom in. It trains them to deal with critique and feedback. I don't think there is any other model that does it. And we tell the students about this process so they are more prepared to kind of to anticipate this. But the idea is that this does not just happen because we are telling the kids this is what needs to happen. It happens because they do it over 1 million times during their education here. When people talk about a school as a human enterprise, they should come here and see it. I think a lot of what we do in traditional education is almost take the human side of it, right? Because everybody is learning the same textbook, everybody is responding the same way, everybody is, you're automating the process as much as you can, so you don't necessarily see all the humans and their kind of full feelings in front of you. But what we do here is the opposite, right? They are bringing everything. Sometimes it's they are not agreeing with another teammate, and so they have, we have to figure out how to solve it. The coach sometimes said something too harsh, and so they have to come to someone else in that space. And I think that what makes this place really fun.
Yes, it seems very technology and making things, but in some ways more like an art school, like for it's like someone who's doing like music or dance or painting. Like there's this process aspect.
Exactly as you said, it's the process. We want to, like, whatever you're doing, writing a poetry or doing a theater or writing an experiment, to do chemistry experiment or a physics thing or math, it's all for us. It's all kind of, as long as it follows the same process, we're good with that.
So can we talk with a student and see what's going on?
Yeah, I think you will. I would like to say something. I think you will be surprised how a lot more articulate than me they are about actually describing their process. And so it's always kind of fun to talk to the kids and see what they are up to.
Hi, I'm Caroline. I'm a junior.
Hi, I'm Gibran. I'm also a junior.
Hi, I'm Lloyd. I'm also as well a junior. So a studio is sort of like a class, but it takes like the span of like a month. During a studio, generally you do like a deep dive into a topic and you learn a lot about like different skills related to this topic. And then sort of generally there's some sort of, not always, but a lot of times we're very like tech heavy school. So a lot of times there's some sort of like fabrication element or like prototyping or research.
Our project, what we worked on in that studio, we call it Solar for Syria. And so what we're working on is leveraging our existing connections in the solar industry kind of here and as well there to get free or very low cost solar panels to work on installing them, like for the schools. And we looked into kind of solar potential. The school is in this place called Rahaiba in Rif Damashq in Syria. And that area specifically has lots of solar potential. It's very sunny. There's more than 330 sunny days a year. So it's very high potential for solar. And so we did calculations. We used this software called Helioscope to figure out how many panels we need and what type of panels we need. And then we kind of got in touch with solar manufacturers who are local, like in the Middle East. We got in touch with the Syrian division. We talked with electrical engineers to kind of figure out
how it all works,
how to wire it.
Mm-hmm. And that's our project, like long term. But for our specific studio, we created educational material surrounding solar panels. So when the solar panels are implemented, hopefully the kids can like understand them and continue to upkeep them.
Yeah, to maintain them. As of right now, we're talking with the Syrian distribution division of Philadelphia Solar, which is a Jordanian solar company that my dad had connections to. And so we have confirmation of the stock of the specific type of panels we're going to be using. So what's next is we know the specific amount of panels that need to be on the school. They need 54 400-watt solar panels. Mm-hmm. So we are going to be working on the logistics of who's picking them up, who's bringing them to the school, and who's installing them. And so for that, we are planning to do a little bit of a fundraiser because we're starting with one pilot school. The hope is that after we see success with this pilot school, we can use that as something to raise actual substantial money to use it as a model for the other about 20 schools in the area that need it. And so in terms of that, right now we're going to start our small fundraiser for the pilot school, which is the solar panels we're getting for free as kind of a gift.
But also inverters and batteries. Other expensive
junction
materials.
Boxes, that kind of thing need to be replaced. They don't have that up to date. We calculated kind of the power consumption of each school based off the information they gave us.
Mm-hmm. End goal for us, I think, is to see the solar panels on the school and the students are able to have a lot of resources we have because of electricity.
I think goal number one is to finish the pilot school. And so that entails actually sending out our donation request to a list of contacts we've compiled who we think might be generous for this kind of project, might have a soft spot. And so that money is to buy things like we said, inverters, breakers, that kind of thing they don't have, and batteries as well. We are going with very minimal batteries for especially our pilot because they are very expensive and we don't want to make it cost too much that it's going to take extra time. This is just a pilot. We want to get it done and see that it works. I would say the end goal is to get 20 schools, to get them all done, to scale it up and to kind of finish it. We plan to work on this over the summer as well, because obviously by the end of the school year, in a few days, it's not going to be solar panels on the roof, but hopefully maybe in the next month or two, we can have the solar panels installed.
For my project, for the overall scope of the studio, we started with thinking about grids. And the grid that I sort of found most interest or intrigued with was the communication grid. I knew at the beginning of the project that I wanted to create some sort of kit or guide to show the students how they could create their own form of communication grid, but I didn't quite know what that would look like, if it was some sort of phone type of device, if it was like more like a walkie-talkie. So we're just sort of like trying to identify at the beginning of the project like what I wanted to work on. And as we sort of began this project, we were sort of just like experimenting with different like sort of methods and like mediums. So we sort of started off with some messing around with like antennas and like really like cheap little radio modules that we could use with like small microcontrollers that we could like program and test like sending out signals and receiving. Another thing we looked at, which we ended up using for like our final project, was something called Meshtastic. Meshtastic is like a firmware system that can be used on a series of a ton of like low power communication devices. It uses a frequency called LoRa, which is like anyone can use it. You don't need to have like a license. Once we found Meshtastic and we were still sort of thinking about what like a curriculum or guide or kit might look like, we talked to the schools and we're sort of trying to identify like what this might look like. But one of our like experimentations we did has sort of like pushed us in this direction of creating a curriculum explaining about sort of like what Meshtastic is and what is interesting and cool about it, along with sort of physical guide to maybe allow them to like create or interact with a device that we would like provide to them in some way. The idea with these devices is that we could give them a ton of like small, cheap devices, and they each form like a mesh network. And the idea behind a mesh network is like, say I'm trying to talk to Gibran, I could emit a message, and if you have like 3 devices, the first device could like emit that message, but it might not make it to the third one. So since they're all Meshtastic devices, device 2 might hear it and would re-emit it so that the third device would be able to hear it. And if you sort of like expand this concept with some software that I did not write, that's sort of like this open source already pre-existing like Meshtastic software has made, it allows you to like transmit like really far distances with like really cheap devices. Like this device here was sort of just like a personal experimentation. This isn't really what I'm hoping to like have them assemble, because it would be like really difficult and annoying to sort of like learn how to do. Like you'd have to have access like a 3D printer and solder, but so on and so forth. With Meshtastic, it would allow them to communicate really far. Like this device here that was like $10, I'm able to communicate with like devices in like New York from, because there's like lots of people in like the Boston area that have these devices that allow them to communicate.
My name is Jade Vincent. I'm a junior at NuVu, and my project was all about making 3D printed open source insulin pumps. And this was to try to really encourage people to customize their pumps and like understand this device, which basically replaces one of their organs. So it's like part of their body. And right now they don't have like intellectual control over it. And I thought that was dumb, so I made this project. I originally got involved with the project because my dad, brother, and uncle are all type 1 diabetics. And then I got really involved with open source tech. Once I kind of built this open source worldview and like, hey, we should like liberate tech, people should own their technology, I looked at insulin pumps, which I'd always taken for granted, and was like, what the heck? My dad's like being kept alive by something that's like designed and built like an iPhone. Like it looks like an iPhone, and the IP around it is treated pretty similarly. Like it's all locked down and confidential. So I started by approaching it from a very like technical utilitarian aspect. So I did some technical development for a little while based off of that like assumption. And there was actually some previous research done by somebody in, I believe it was New Zealand, named Matthew Payne. What he was doing was like making 3D printed insulin pumps just to make them cheaper, so he was able to make like a $90 pump. And after looking at that study and his research, I realized that his pump was like a clinical study. It was just an item to prove, hey, we can 3D print insulin pumps. And that's kind of what I was doing as well. But like that was already done, so I wasn't really doing anything new. So I kind of changed my goal to make a 3D printed insulin pump that's user-friendly and oriented around like the user experience. So I reached out to a bunch of different users, where eventually I met one of my friend's moms who has type 1 diabetes. I believe she was like diagnosed when she was 50. So she like had to figure it out when she was like an adult. Meanwhile, a lot of people, it's like while they're a teen, which makes everything easier. And this was a really interesting use case, because like all insulin pumps until very recently were kind of designed around one user profile, which is like a guy with a desk job. And diabetes doesn't target just guys with desk jobs. It's a genetic disorder. She felt really underserved. by her pump's design because she like hated technology and she really just wanted like simplicity and durability. Meanwhile, her current pump is like a industry leading device with all these like charts and numbers and like it's like this delicate little gadget, and she hated that. So I decided to design a like concept of an insulin pump that like she could 3D print using open source tech. So basically being like, hey, Matthew Payne made all this tech. We don't need to reinvent the wheel. How might we apply this? So imagining a future where 3D printing isn't just being used to make pumps cheaper, but it's being used to like let each person have like their own custom pump that's like designed around their own needs. The final product is this like big, strong, robust thing. It only has 4 buttons and 3 switches instead of a finicky touchscreen. It has like this silicone bumper going all around it, and it's like this really organic, almost flask shape. She mentioned liking the idea of like a bubble, which needed to be longer than flask shape, and I was starting to like doubt that design decision. And then I had a feedback session with her and she was like, oh my God, this is like exactly what I want. This is great. So that felt really great and reaffirming and kind of reminded me like, yeah, I'm designing for this user, not the guys trying to get desk jobs, basically. The big vision is to make like on GitHub or whatever file sharing network have like a technical framework where you have like a module where it's like, this is the motor and the reservoir that holds the insulin and the motor spins and it like drives a screw on the shaft that infuses insulin into the person's body. And then you have like the control computer that has like a precision clock and like all that stuff. So these like technical like modules that people then can take into like their own 3D modeling software, whether it be like a professional software like SolidWorks or Fusion 360, or like, I mean, theoretically even like Tinkercad, like something made for like literal children. But like take these modules, bring it into their own software and design a form that really suits them, and not having to worry about like, am I gonna accidentally kill myself with this device because I don't understand the like technical framework enough. It'll really just be like having that all dealt with and being able to design their like dream aesthetic and dream form factor. Actually, I think I do have some photos of this, but do you guys know like Gravity Falls? Do you? Yeah. One of my early form prototypes for an insulin pump was like an insulin pump covered in Grunkle Stan decals to kind of create like, hey, what if we made an insulin pump that like encouraged you to put like a fun like children's decal on it or something. So like, yeah, if like a dad had a kid that really loved Bluey, you can make like a little like Bluey plush insulin pump.
This is my board, this is my project. It was called Define and Design. And kind of what the point of it was is we wanted to make kind of abstract versions of parts of the design process at NuVu. And like we wanted to kind of turn it into like fun, playful kind of games and activities that like kids could use, like kind of elementary school age kids. So we could explain to them kind of like the NuVu design process, but like in a fun way. So ours were Define and Design. So like this top half of the project, it's like a target. And the point of it was kind of to like, you're kind of defining a project, like you're defining the idea that you want for your project. And the point of it is that like, it's a target. So it kind of like zooms in and that's you like narrowing down your idea. And then this one down here, this was Design. And it's kind of like a 3-in-a-row game. You can kind of like make these match and stuff and like play a game with it. But our goal was kind of like, because it's supposed to be design, we wanted to kind of, when people are playing this game, you kind of have to like pick a path, like a way you want to like match them. So it's kind of like you're thinking of ideas, you know, you're creating ideas. And then if someone else like changes something that you already did, it's kind of like someone giving you feedback on your project and you having to kind of like change your ideas and reiterate a little bit.
I'm Beckett. I'm a senior at NuVu High School. I've been here just under 5 years. Yeah, I love it.
Yeah. So can you talk a little bit about how you know this experience is very different than other people your age?
We have a lot more freedom almost immediately. So the big thing that differentiates NuVu from like a traditional high school is that we're not spending our time doing kind of like English, math, and science classes. We are creating projects. So that really starts with kind of identifying problems, and a lot of that is presented to us by our coaches. So we don't have teachers, we have coaches who give us these like problem statements. I'll give an example, actually, maybe this is the best way to understand it. I was working on a team that was building re-entry housing for people who are just coming out of long-term prison sentences. And this was in collaboration with a group called AHIMSA. They're in Oakland, California. And this is what they do. They make re-entry housing kind of communities for long-term incarcerated people. And we actually got to speak to the people who run these programs. We had a kind of a touch person there, and she kind of gave us the rundown of this is what a housing looks like for people who are just coming out of long-term incarceration. These are the problems with it. These are the kind of constraints and the regulations. And then we were kind of put to work. And that's kind of where that freedom I was talking about comes into play. It was really our responsibility to take the information that we'd been given, dig deeper, do our research. We actually had the amazing opportunity to fly to Oakland, California, and talk to people in these communities, in these kind of reentry housing communities, and find out their needs, find out their wants, kind of like understand their experience, and then kind of come back to Cambridge and working with long-term professional architects, produce a proposal, I guess would be the word, for the AHIMSA group for this reentry housing community. And we kind of worked through, the full step of what that means as an architecture project, from the kind of diagramming to the site analysis to the kind of like regulation and legal aspects of it, all the way up to producing kind of a full architectural render, using kind of industry standard software.
Wow. So you get this real world problem.
Exactly.
And you get the introduction from the coach or the person at the organization. Can you talk about any drawbacks during the process of not having had the context or lived experience of someone who might have been working in this area for a while?
Yeah, totally. I think that, right, when you talk about like a drawback, I think that there's like two ways to think about that. The first is, as someone who, I'm not coming out of incarceration, right? I'm not kind of in that experience. My design, whatever kind of product I produce, is going to be in some way detached from that experience inherently. And, if I'm thinking about like a designer, that's kind of suboptimal in some way, is my kind of like answer as a designer. And then I think as a student, when you're kind of in a project to learn, it's easy to kind of lose yourself in this like dichotomy of both being a student and a designer, where the proposal that we produce may be kind of like suboptimal, or like, I don't have the skills to do X, Y, or Z yet because I haven't been exposed to that. My designer brain tells me like, oh, you shouldn't be the one doing that then. Like, you don't have that kind of expertise, that's not your skill set, you should pass that on. And then the student brain is saying like, no, you have to learn, you have to engage with these contexts.
So in these past 4 and plus years, you've had how many studios, or how many real world problems?
That's a great question.
Or approximately?
So we work on trimesters. Every trimester has a studio, so it's like 1 problem, 2 problem, and then we have a time called open innovation, where instead of the coaches being kind of the one who's presenting us with these problems, we go out and we find our own. And then we kind of build off that. So there's, I guess, 9 projects a year, over 4 years, probably plus a couple, because I came kind of halfway through. I would say roughly 40 projects in my time.
Okay. And can you talk about another one that stands out?
Yeah. Well, so I'm a senior now.
Okay.
And every senior that goes off and graduates, we have to complete a senior capstone.
Okay.
So, most of the studios take about anywhere from like 3 to 4 weeks of our time. So they're very short when you think about like the work that you have to do. A capstone is 3 months. So it's this huge kind of elongated time. And similar to open innovation, it is completely self-guided. So it's meant to kind of take the skills that you have learned in your time here, solving all these problems, and kind of, take the reins, go do something yourself. So for my capstone project, it was really intended to be kind of a continuation of a previous studio. There was a previous studio called Off the Grid Systems, and I was working with these kind of decentralized communication networks, and kind of that was really kind of my passion. So as I begin kind of in that early phase of my capstone project, just what the hell do I want to do? I kind of fell back on that as this like passion. I started researching what are called like cell site simulators, or kind of like DIY cell towers that people were making. And it's actually just kind of happenstance through my research that I discovered that these were devices that were also used by the Boston Police Department, which was a little curious to me and a little concerning because the main exposure that I've had to these devices is as spyware. So I kind of walked this rabbit hole a little bit, and like I was all of a sudden doing a project on the kind of dangers of police surveillance. And I had like the amazing opportunity to talk to like experts. I got to talk to kind of ex-police lieutenants in the Boston Police Department, people who specialize in like ethical policing or working with police training centers. I got to talk with amazing kind of people at the MIT Radio Lab, and the kind of culmination of this work was creating a device that could detect when your mobile devices were being surveilled remotely by the Boston Police Department.
Wow.
And because I had kind of the whole process of this like research and exploration, it kind of made me feel overwhelmed, and it was like kind of a difficult topic to dive into. I felt like it might be for other people like me. So throughout the entire time, I was kind of videotaping and documenting my process, and I compiled that footage into kind of a short documentary film of kind of like, this is my experience with police surveillance, and these are why I think it's concerning.
Wow, that's great.
Yeah.
So you're heading off to Carnegie Mellon.
I'm heading off to Carnegie Mellon.
Amazing.
Yeah, very, very exciting.
Yeah.
I'm going off to do design at Carnegie Mellon, which is super exciting.
Cool. And I would love to know what, because you talked about freedom, the freedom when you first got here, and then here at the end you had this big open-ended 3 months. What would you say is the most important thing you learned, or learned even about yourself and your style, that enabled you to take that 3 months and use it really productively, or that you're going to carry into your work at Carnegie Mellon?
I think that I'm going to pick two things because I can't pick one.
Okay.
The first is design is so much more of like a way of thinking than it is some sort of like physical discipline, and learning kind of the mindset and how to think as a designer, and how to like look for problems and how problems get solved effectively. Working that mental muscle constantly for 4 years is irreplaceable, I think. Like, if I had to pick one skill that I learned, it was definitely that way of thinking.
Okay.
And I think personally, being in an environment that is so open-ended and encourages all this freedom, you really have to learn to be confident in yourself. And you really have to learn to not only like trust yourself, but you're dealing with such complicated and like multifaceted problems, and you're expected to deliver solutions. And you have to really like drill into yourself that your ideas matter and are helpful and are good. No matter if you, whatever age or whatever technical experience you have in an area, your ideas can contribute. And really like believing that for yourself and presenting your ideas with confidence and like standing behind them and being able to defend them is a huge moment of like personal growth, I feel, for myself, not only in high school, but definitely going off into the college and beyond.
Yeah, well, you're ahead of the game, having learned that at your age. Thanks for chatting.
Yeah, thank you so much.
It's really nice meeting you, Beckett.
You too.